Video 5. The K-parameter and variance. Not all PMM is created equal. Welcome back to Second Breakfast AI. We've been saying pick from the 5 closest matches, but why 5? And is there only one way to do PMM? Let's tackle both questions. The K-parameter is your donor pool size. It matters. If K equals 1, you always pick the single closest match, no randomness. 2 similar cases get the exact same imputed value. You've basically recreated the variance compression problem. If K equals 50, your similar cases might not actually be similar. You're pulling from too wide a range. Matches get sloppy. The conventional default is K equals 5, small enough for genuine similarity, large enough for appropriate variability. Research suggests the method is robust from about 3 to 10. Now, here's something that surprises people. There isn't just one PMM. There are several variants, and different software implements different versions. Type 0, or PMM with fixed coefficients, is the basic version I've described. Estimate coefficients once, predict, match. Simple, but underestimates uncertainty. Type 1, or Bootstrap PMM, re-estimates coefficients for each imputation using a bootstrap sample. This propagates uncertainty in the model estimates into your imputations. Type 2, or Bayesian PMM, draws coefficients from their posterior distribution. Then there are specialized variants. Midastouch weights donors by distance instead of using a hard cutoff. The closest match might have 40% chance of selection, the second closest 25%, and so on. Helps when donor pools are sparse. Local residual draws add noise based on nearby residuals, useful when you need values outside the exact observed range. Which should you use? For most work, your software's default, usually Type 1, is fine. For serious research, consider Type 2. If you see the same donors repeatedly, try Midastouch. The key point: know what your software is doing. Mice in R, iterative imputer in Python, Stata's MI, they have different defaults. This can explain why results differ across platforms. In the next video, we'll dive into the mathematical foundations for those who want to understand what's really happening under the hood.